So, welcome everyone and good afternoon. I hope you are all doing great and had a good morning this today. So, this is our second lecture on requirements validation and management from this requirements engineering part of the course. And before we start, do we have any questions from the last lecture? I just want to ask. I also saw some questions on Slack during this week. So during after the previous lecture and today, but I just also want to mention that I published some slots on my Moodle. So for each slot, I guess 4 or 5 students can book at a time, and that is to make sure that everybody can get in because of the limited number of slots. But for the tutoring, mainly you should use those slots based on the assignment, or if you have any questions on the assignment. In particular, we will have a hands-on session next lecture, I think next Tuesday. So you should go through those materials from hands-on session, and if you have any question, you can ask during the tutoring sessions. And with that, let's start our today's lecture, which is about requirements validation and management. In the previous lecture, we talked about how we can elicit requirements, how we can involve different stakeholders in finding out our requirements, and then how we can analyze those requirements, like using systematic analysis. For example, you are using a form based on multiple questions. And today we look on how we can validate requirements and how we can do something to manage our requirements in a systematic way. So basically, today we will have 2 parts. One is for the validation and one is for the management. So validation, what do we mean by validation? It's about checking the requirements to identify possible problems in the requirements. It's similar to requirements analysis, but not exactly. There are some slight difference between requirements analysis and requirements validation. So in the requirements validation step, you should also involve different stakeholders, requirements engineers, designers, and so on, so that each of those stakeholders can have their voice to discuss the requirements or to validate the requirements. So what are those common problems during this phase of requirements validation? So one of the key problems is the conformance to the quality standards. So this standard can be the document standard itself. So if the requirements document or the draft that we are writing does it conform to the quality guideline or the standards that are proposed? I think I introduced one of the standard before in the previous lecture. And then also similar to the requirements analysis phase, we also need to look for ambiguous requirements, requirements that are poorly ordered. And this ambiguity issue is coming back again and again, as you can see, because ambiguous requirements are not very useful. So if you want your requirements well developed, well understood, well tested, it should not be ambiguous at all. And then also during the requirements validation phase, requirements conflicts are identified that were not detected in the previous phases, or maybe during the requirements analysis phase. Also, feel free to ask questions similarly on YouTube chat or on Slack. So I'm following them in another window in front of me, so I will probably not miss any questions. So all these problems like conformance to the quality standards, ambiguity, conflicts among the requirements, they should be identified and solved before you produce your final requirements document. So what's an example of a requirement conflict? So there can be many examples, but one example could be one stakeholders want authentication based on user ID and password. Another stakeholders might want or may look for different types of authentication. It can be mobile authentication, it can be third-party authentication, it can be email validation, and so on. So if there is this kind of conflicting requirements, then those two stakeholders should agree to a mutual statement that clearly define that requirements, that authentication requirements, and so that developers don't need to do repetitive work, or there should not be any repetitive requirements and so on. So if you remember this spiral view of the requirements engineering process, in the previous lecture, we mostly talked about requirements elicitation and requirements specification, but today we will talk mostly about requirements validation. And also, once you have your requirements document, basically you are in the implementation phase, and after that phase or during that phase there is also requirements management phase. So we will cover this management phase and validation phase both today. So there was a question that I raised in the beginning. So what is the difference between requirements analysis and requirements validation? Because both of them identifies problems in the requirements or in the requirements statements. So what do you think would be the major difference between them? Any clue or any thoughts from your side? I'm just waiting for a single response and then I can proceed. But if there is no response, I can also proceed with my answer. So the main difference between requirements analysis and the validation is that requirements analysis phase concerns with the requirements that are raw text or high-level requirements in natural language from various stakeholders, and then it tries to minimize conflicts or issues within the requirements. But requirements validation phase work based on the specified requirements or based on the requirements specification phase, and the outcome of requirements specification phase can be more stable requirements or requirements in different notations using graphical notations or any other form. So that is the main difference. And during the requirements analysis phase, the goal is more to identify incomplete requirements or to identify requirements that are not well defined. But in the requirements validation phase, the goal is to more ensure that requirements are not only described well, but they are also presented well in the form of documents or when it comes to standards and so on. And the reason requirements validation step is more important, because once you finish this validation step, basically there is no go back for the developers or for the designers, because your requirements document are already finalized. And if you want to, let's say, correct any errors in your requirements that are already developed or under development or delivered, then the cost could be up to 100%, 100 times than if you identify the errors in the requirements or in the requirements document in the early stages, like in the requirements analysis phase or in the requirements validation phase. And for this requirements validation, one key step, as I mentioned, is to make sure that your requirements document has followed a standard. And this standard, of course, can vary across organizations, but then your requirements document should be not only well structured, but also uh, the requirements themselves should be consistent with the standards. And if you have a requirements document that is synced with a standard, that means it's easy to find problems, because in the standard there is some uh, obligatory sections or some obligatory parts that you need to define for each requirements, and there can be some optional or non-obligatory sections. So following a standard or a document standard, or it can be a quality standard, it helps you to find further problems in your requirements, or if there is something missing in your requirements specification. And this check with the quality standard or requirement standard documents should be done by an engineer or analyst who is not, or who was not part of the requirements elicitation, because of not to bias him or her, and having this third opinion will improve your requirements eventually. So this quality check with the requirements standard or standard document should be done by a person who was not involved in requirements gathering phase. There are many ways to perform this check that your requirements document correspond or conforms to some standards. One way is to compare the document structures and highlight missing or incomplete sections. So this is from the structural side, and then from the content side, we have to make sure that all pages have numbers, all diagrams or tables are labeled, and then there is no incomplete requirements, there is no incomplete sections, and so on. So for your assignment, you are also not only the person who is gathering the requirement, but you are also the person or the analyst who are making sure that your requirements document is meeting the standards. So sometimes it could be biased, or it might not be a good idea, but since you are working alone in your assignment, you have to make sure that your requirements document include these informations or these quality standards. So what's next if there is problems or deviations from the standards? So there are two alternative way. So one is to return the requirements document or the draft of the requirements document to the requirements engineers or the team, if there are more people, to correct those problems or deviations if there is enough time. But this is not the case always. So the second solution is to note down those problems in the requirements document or in a separate document, and then provide these to the formal reviewers, because as an analyst you are only checking your requirements document if or whether they meet the standards. So once that is done, the next phase, that is the reviewing phase, that is also the formal review, is conducted. So the people or the person who is checking the quality standard of the requirements document write notes and give them directly to the reviewers, and it saves time and cost of revising or creating a new version of the requirements document. And usually number two is preferable when there is tight deadline and the errors are minor, obviously. So during this review phase, or once you are done with the uh, standard check with the document between the requirements document and and the quality standard, all the or other standards, then the next phase is to review. So review means formal inspection of the requirements, and again this should be also done by a group of people from your stakeholders list, and you have to make sure that they have different backgrounds and different skills, different knowledge to bring the diversity in your requirements inspection team. And if you do a formal requirements inspection, it's also a cost-effective way of finding problems before you finalize your requirements document. And your requirements inspection meetings should not be about blaming for the problems that has been discovered. Rather than those problems should be resolved and discussed mutually to solve them. So that's the goal basically for these inspection meetings. And this inspection meeting should be uh, chaired by someone who was also not part of the requirements elicitation. And again, this is not to bias the judgment or to bias the decision, so that we can look at the requirements from the neutral perspective. And during this meeting, inspection meeting, there should be three steps. I think in the previous lecture we discussed that. So the information stage, where each requirements is presented to the audience, then the discussion stage where the problems are discussed in detail, and then the action stage or the final stage where necessary actions are defined or the remediation are discussed. So there was a question on YouTube that says, so the analyst should be a real expert in all areas. Otherwise, how will he validate requirements according to the standards? Yes, I think I also mentioned this in the previous lecture, that an analyst or a requirements engineer who will deal this should be should be expert in the organizational process, or let's say if Jeff Bezos, the owner of Amazon, wanted a system like Amazon we have today, the website, an analyst should know how Amazon work, and then this analyst should also know the company that is going to develop Amazon website, or the company that he is working for. So how that company or that software development firm operates, so or their business process, and also the problem domain itself. So the analyst should know how e-commerce work, or how purchasing, return, or different types of products should be presented to the customers, and so on. So this analyst should be knowledgeable on these three aspects. So the problem domain, the organizational business process of the end users, and the organizational operational process or operational knowledge of the software development company that's going to develop this system. Yeah, but that's a interesting question. So what should we do once we identify problems in this requirements validation phase? So if there is some requirements clarification issue, probably that's because of the requirements are badly expressed. We need to rewrite those requirements. If there is a missing information, engineers should try to discover those missing information, and they can do it by talking with the stakeholders and then rewrite also or update the requirements. And then if there is any conflicting requirements, I give an example based on the question by Atakan, that if there is any conflicting requirements, then there should be some negotiation between stakeholders to establish one requirement. And if there is any unrealistic requirement, we should consider either modify it to make it realistic or delete that requirements. So we are talking about inspection, and that the goal of this inspection team is to review the requirements. And we also mentioned that this inspection team should be composed of multidisciplinary team with diverse background. So multidisciplinary team means people from the domain expert, people from the development group, people from the people who will be using this system. So maybe they are representative also, or the designers or requirements engineers who will be working, who will be designing the system based on the requirements. So this team should be multidisciplinary, and there is of course a benefit of it, like people with different skills and knowledge and experience brings different perspective. And if let's say we have different types of users in the team, or not users, different type of stakeholders in the team, being an end user, I might not have any knowledge of the domain or of the software engineering concepts. It's also same for vice versa. So being a developer or tester, or I might not have domain knowledge or some end user perspective. So having all those multi view or multidisciplinary perspective in the team gives or helps the team members to share ideas and develop their understanding on the overall system. So there are many benefits of having this multidisciplinary team for inspecting the requirements. And this requirements validation can be also done through a validation checklist. So if you remember, we had an requirements analysis checklist, and then now we also have a requirements validation checklist. So this can be also applied in the same way that a requirements analysis checklist can be applied. So the idea here is to ask each question for all the requirements, or for each requirements ask all the questions, and then do a overall judgment or overall analysis of the requirements to try to revise the requirements by finding some problems within the requirements. So defining this kind of requirements validation checklist also have some benefits. For example, it defines a structure or a systematic process for the validation. And then if there are any new developers or new engineers or even new members as a stakeholders, they can use this validation checklist, and they can also uh, feel themselves as part of the system, even being a new member without any prior knowledge. So they can use this checklist also to assess the requirements. And finally, of course, the management and the end users who might not have any technical or requirements validation expertise, they can also use this checklist to quickly identify problems from the requirements. So this validation checklist can be used by any people, in other words. So what are those questions, or what is the validation checklist? So the validation checklist have these 7 questions. I think requirements analysis had 8 questions. So the goal here is you ask these 7 questions for each requirements, and then uh, make an overall assessment for that requirements. And in this case, you can also use that matrix format or table format, where you can have validation questions in the rows, and in the columns you can have requirements, and then you ask the same questions for all the requirements, and then you do some assessment of the validation outcomes. But also eventually the end goal for this validation checklist is to revise your requirements if need be. So I'm not going through those each of the individual validation checklist, but they are obvious and self explanatory. So if you have any problems understanding them, uh, you are welcome to also ask questions during the tutoring sessions. But you will need to use this validation checklist also as part of your assignment. So make sure you understand them well. So there is a question also on YouTube. Is the requirements validation same the same process as analysis, but just on different stages of the requirements, or the process can be different as well? I think the process is also a little bit different, because not all the questions are same in these checklists, and then they are also done in different phases. So both are true. So requirements analysis is done prior to requirements specification. Rather, requirements validation is done after requirements specification. So we are still talking about requirements validation, and one of the easy and more popular way of requirements validation is using prototyping. That means you are building a dummy representation of your system and try to understand its stakeholders, or try to get their impression to find out that if there are any missing requirements, or if something should be improved or not. There are many benefits for the prototyping. For example, you can of course discover problems for and suggest improvement for your requirements as early as possible. Then, if for example you are writing a prototype using a user-friendly technology, that so what I mean by user-friendly technology is that you don't need to write much code, and that system is still usable, then you can use that prototype as a stopgap system if there is any uh, serious delay or some kind of failure of the development for the actual system. So this prototype system can be used, for example, as an interim system. And also, if you are going to implement prototype, the real prototype here, you might find some more inconsistencies or incompleteness in your requirements document, because until you go for the implementation of your requirements, you might not understand some of the problems. So prototyping is one good way of validating your requirements. So I think I will be discussing three major or popular way of prototyping. One is, of course, the paper prototyping, and then there is also another one is that is Wizard of Oz prototyping, and the third one is more realistic, using high-level fourth generation language. So proper prototyping is a method for creating a mock-up of a system using only pen and paper. Uh, it has some benefits. Also, it has some cons. So the benefit is that it's a really cheap and effective way to represent a system and to find out problems from the end user or based on their feedback. So what you do, you usually uh, draw screens, imaginary screens, and then you transit from one screen to another screen, and simulate your scenarios based on the use cases, for example. So what analyst or requirement analyst does is go through these scenarios that you draw on the paper and discuss with the users and get their reactions or feedback to see uh, how they interact with the system, what they think of the system, and what can be done further to improve the system. So here is an example. This is also a famous example from BBC. Uh, so the exemplar problem is that Joe wants to listen to a radio program on a radio device rather than on her laptop. She wants to find available devices around her. It can be any type of device, Bluetooth device, Wi-Fi device, or even mobile devices. And so she finds the devices available around her. Choose one device and play the program or song on that device. So she can do it in two ways. Uh, that or she want to do it in two ways, either by sending the stream to the device via the laptop, so she can play the music or the radio on the laptop that will stream to that device, or she can tell the device to play the stream, let's say either verbally or from mobile or any other sources. So how can we do paper prototyping, or how the analyst can do paper prototyping for this kind of requirements? So this is the example solution. Let's say Joe. So the analyst draw an interface like this. Uh, so it's a laptop of Joe, where she is opening this app, and when she click on the uh, play button, or she wants to play something, it opens a number of available devices that she can play her music on. So this is another uh, representation of another interface, and then she can choose a radio device uh, in which uh, the song she will be playing from her laptop will be synced or streamed. Basically, they are playing the same music. So this just shows, for example, that the music is being played. Even she closes her laptop, the music continues to play, and then if she opens her phone, she can basically change the source and now she is playing music from her phone, and she can not only change the source, she can also change the destination device. So from her phone, uh, she is playing the music on her TV. Uh, there was a question also on YouTube that says, are these not called wireframes? So what do you mean by wireframes here, Richard? Okay, I guess Richard is trying to write something. In the moment, I will proceed. So this is one example of paper prototyping. And then analysts, uh, together with the user, go through each of those interfaces and discuss them in detail, and what is expected, what is not expected, what can be done differently, and so on. So in this way, the requirements can be revised if needed. So the second approach is the Wizard of Oz. So Wizard of Oz is basically a role-playing uh, prototyping method. So it's also similar to paper prototyping. So I got a response from Richard now, who says a wireframe is a two-dimensional illustration of a page interface that is specifically focused on space allocation and prioritization of the content. I am not personally familiar with wireframes, but yes, you could be right. But I think this kind of uh, concepts are not so that much used in software engineering, or at least in recurrence engineering. Perhaps they are from different domains, but yes, the concept is right, what Richard mentioned. Yes, the second one is Wizard of Oz. So what I was mentioning, that it's a role-playing uh, prototyping method similar to the paper prototyping, but it also have some more benefits, or some more clear way to interact with the users, and to find the problems in the requirements. So this is also a relatively cheaper way of prototyping a system, similar to paper-based prototype. I think I have a movie in the next slide where we can watch how this Wizard of Oz prototyping works, to give you some idea. I guess you will be able to listen to this. Hello, this is a Wizard of Oz prototyping technique, and this application called DIAX, and it's a diet application. You can sign in with your Google or Facebook accounts, or if you want, you can create your own DIAX application account. To do that, just click on sign up. Then this page comes, and then fill in the blanks, then click on sign up. And then sign in page comes. Just enter your username, password, then sign in, and home page welcomes you. And we have a side panel. If we drag our finger from the edge to the center, then we see this side panel. We have many items here, and then we go over them one by one. Just click on diet program. Here in diet program, we can choose our diet program, which diet we want to do, and then drag our finger to go to next item. And then here we have tracker. If you click tracker, then here tracker we have a graphic, and here we can choose, we can. So I guess you could understand how this Wizard of Oz prototyping works. I don't want to play the full video, but that's the idea. So someone is playing the role of user here, but still based on the paper prototyping, and he is particularly showing what's the input and output for each of those interfaces or for each of those steps. So I think this is more useful than pen and paper only prototyping, but still it does not allow you to interact with the real system. So to solve
Hello,
that
this is
problem, there is another prototyping method, that is automated prototyping. And usually this automated prototyping is done with fourth generation language. Uh, so for this the properties of this fourth generation language is that they need very few code to produce a working system. So they might involve the database within themselves. For example, Visual Fox Pro or Visual Dataflex or even Power Builder, they all give you this opportunity to generate interface as well as have a database that interact with that database. And this is also a uh, very executable, or it's possible to execute this automated prototype. And also another benefit of this prototype is that, let's say, uh, you are delaying your development uh, due to many reasons. This automated prototype can be used as a stopgap system. So for the moment, you can provide this automated prototype. Users can use this until you have the final version or the real software that was to be intended. Uh, Sometimes you might not be able to test some some aspect of the systems. For example, using prototype or using this automated prototype or other prototypes, we can uh, test functional requirements, or we can check if the functional requirements are implemented or not, but we cannot test non-functional requirements in this case, or the requirements that are global requirements, or the requirements that are applicable to the whole system. This includes performance, efficiency, usability, and so on. And also, uh, if you are developing a automated system or automated prototype, sorry, then the performance that you have or usability that you have in the automated prototype might not be the same that compared to the performance for the final product. So they might improve a lot, or vice versa. So for the requirements validation, we are still in the phase of requirements validation, and one of the steps could be to write a draft user manual. So if you consider your requirements document a system specification, that means what requirements should be implemented or what is we have in the system. And based on this requirements document, if you write a user manual, that can be your future final user manual too. And usually there are many benefits of writing draft user manual, including if you are going to write a user manual based on your draft user requirements. That means you need to do a detailed analysis or a detailed thinking of your requirements, and you are still able to find further problems uh, in the requirements if you are not able to write a uh, draft user manual. So the user manual usually tells you how to use this requirement, And if you are not able to write such draft user, that means your requirements have problems. So this draft user manual is another way to find problems in your requirements. That means it's also another way to validate your requirements. And this can be achieved by basically translating your functionalities in the requirements document into how we can use that functionality or how we can perform that functionality. Of course, the person who is writing this user manual should make some plausible assumptions or some imaginary actions. But then if the person is not able to make some plausible assumptions, so plausible here means logical assumptions based on your requirements, that means your requirements also have problems. So you still have the opportunity to improve your requirements. Another way to validate your requirements is that test cases. So you should be able to write test cases for your requirements even early in the process before you implement that requirements. So by writing test cases or proposing test cases does not mean that you have to write code. Rather than you should focus which aspect or what aspect of the requirements you are going to test or you want to test. So I think also uh, uh, writing test cases for your requirements will be part of your assignment, but many of you misunderstand these instructions that I will be giving and come up with a detailed test cases. What are the preconditions, what are the post conditions, what are the inputs, what are the outputs, and so on. I don't want that detailed test cases at this point. Even for the requirements validation, you don't need to provide detailed test cases. Rather, you should focus uh, which aspect or which part of the requirements should be tested or is testable. And this also identifies incompleteness or ambiguity in your requirements. I hope I could make this clear because this is also an important part of your assignment. So when I will be asking to write test cases, don't write detailed test case. Rather than identify what aspect of your requirements should be tested. For example, one requirement can be, I want a authentication system that allow an user maximum 3 times or 3 tries, and once he failed 3 times, the account should be blocked. So one test case for this requirement could be if whether or if the number of tries is less than or maximum 3, less than or equal to 3. If it's greater than 3, the account should be blocked or the login should be disabled. So this is one example of what test cases we can write from our requirements without going into detail. So how we can implement or how you can write those test cases at this early stage of requirements validation. You can do it by objectively looking at your requirements rather than uh, at the detailed level. And then you should not concern about how you want to test or how long your test should run, or if there is any time limit for your test, how many test cases you need, and so on, what type of test data you need, and so on. So you don't need to think anything about those. At this requirements validation phase, what you need to focus on is what you want to test, not how you want to test. So how you can define a test case? You can define a test case by thinking a use case scenario, by thinking about information. So what information you have in the requirement, or does it include enough information uh, that you can use to define your test case? So if it not the case, that means again your requirements has a problem. You want to make sure that each requirements uh, have, in most cases, have only one test case, or only a single test. If this is the case that your requirements should be tested by multiple test cases, that means your requirements can be broken down into smaller requirements. So it's a compound requirements. So that's another way of validating your requirements also. And you should also have a test recording form. This is not something you should have in your assignment, but this is also a good practice for the testers or for the developers in the real life development companies, that usually they have a test recording form for where for each test they, so they have a requirements identifier, what are the related requirements for that test. So it's basically textual representation of your test case. But this is just for your information. You don't need to work on this in this course. One of the ways of requirements validation is to describe your models. And usually we know that we represent our requirements in the requirements specification stage using different notations, including graphical notations, like it can be class diagram, it can be data flow diagram, it can be component diagram, it can be deployment diagram, and whatnot. So one good practice is to write some short paragraphs, or maybe using some bullet points, uh, how one should read that diagram. I think I have an example in the next slide. Yes. So for example, this is a online order processing system, and this online order processing system, so this is a data flow diagram. So this online order processing system might have different activities, different data that are passing from one activity to another activity. Uh, there are data that works as an input or are produced as an output. There could be some control logic and so on. So all these things should be described very briefly if you are paraphrasing your system models or your requirements specifications. So in this case, so in this case, this is one of your requirements specification, and you are paraphrasing your requirements specification to briefly describe your requirement or your system. So basically, you should have a transformation name. That means, in this case, for example, the process order is a transformation because it takes some input and it produces some output. And it also uses some information from other activities. For example, in this case, username or user address. So you should have briefly mentioned the transformation name, what are the inputs and output, what are the, so what this transformation function is doing, uh, what are the outputs this transformation is, or this activity is producing, and any exception or control information included in the model. For example, one exception could be the payment failed due to incorrect credit card information. So this collection payment might have some uh, exceptions defined as part of this transformation. So you should mention all those in your paraphrasing. Oh, I think we are in the middle of the lecture and it's 55 minutes so far. So we can take a quick break and we can come back at 2:20. So now it's 2:10. So we will come back at uh, 2:20. So see you in 10 minutes. So I guess we can continue. So any questions so far on what we discussed on requirements validation? I just also forgot to mention that I uploaded the slides and the reading materials before the lecture, so you can have a look at the slides during also the lecture. Okay, so we can continue if there is no questions. So the second part, requirements management and how we can manage requirements at various steps or various stages of the life of the requirements, and why this requirements management is critical or essential is also because uh, we do not have the same sets of requirements, neither our requirements never change. So we might have new requirements as over the time, and also our existing requirements might change over the time, and there is a need for well-defined management policy to to include or incorporate those changes in the requirements. And any changes in the requirements uh, not only should reflect in the system, and it's also that's true for the other way. So any changes in the system that was planned originally should be also reflected in the requirements document or in the requirements. And if there is a lack of consistency, the maintenance team will suffer in the future. Uh, and that means the organization itself will suffer. So there should be a process that is called requirements management process to deal with those changing requirements. And this requirements management process usually is concerned about managing changes to the requirements, how various requirements are related, so the relationship between requirements, and also uh, the dependencies between requirements, document, and other software artifacts or other software engineering processes. So, because the requirements document is the outcome of requirements engineering process overall, right? But there can be other sub software engineering processes that might have other uh, outcomes. For example, the architecture documents or the architectural design document might have linked with this requirements document or might have some dependencies with this requirements document. So all these dependencies are also managed by this requirements management process. And while managing these dependencies or relationships, uh, maintaining the traceability information is key, because if we cannot trace requirements across various documents, across various processes, that's very easy to get lost or to lose your requirements. So a requirements is traceable only when you can discover who suggested the requirements, why it was suggested, I mean, uh, how it is related to other requirements. So, I mean, the complete information about a requirements should be part of this traceability information. And one of the key, or one of the early requirement to manage requirements or to handle this traceability information is to give a name to the requirements. So basically, it's identifier. So you should give a unique identifier for each of the requirements, or it can be a reference number. There are some practices. I will come to that later, how to identify requirements. But the benefits of identifying requirements is, of course, that you can uniquely reference those requirements. If you are storing your requirements in a database, you can use those unique identifier as a primary key in your database. And then, let's say if your requirements are changing over time and you need to version your requirements, you can do the versioning based on those unique identifier. One of the most common approach for naming the requirements is, let's say, based on the document structure. So if you have requirements in under a chapter, and that chapter has multiple sections, you can name your requirement based on which page number they appear in, which section they appear in, and which chapter this section is part of. So for example, if you name a requirement that is number 6 in the second section of chapter 4, you can identify that requirements at 4.2.6, but then there is a problem with this, right? And the problem is, let's say we have also 6 requirements in chapter 3 under section 2. So you might name the last requirement or the 6th requirement from chapter 3 as 3.2.6, right? But then the problem here is the understandability problem or the semantic problem, which is you might think, or other people who don't know about this requirement might think that from the name they are similar requirements like 4.2.6 or 3.2.6, which is not the case, and the requirements might be completely different. So having this numbered reference or identifier is not a good idea, according to me at least. What you can do, you can use some similar identifiers, and those identifier can be collected from the requirements statements themselves. For example, if your requirements is about security, you are asking some security functionality, you can say the name of the requirements is SEC and then 0, 1 or 1. So if you have multiple requirements related to security, you can name them sec 1, sec 2, sec 3, and so on. And this form is known as mnemonic form, which is more meaningful and gives more clear picture what is the requirements is about. And one of your goal for the assignment will be eliciting requirements and identifying them. So you must make sure that you will be using this mnemonic form rather than any serial number or any reference number and so on. So I think that I will also mention in the instruction, but try not to use this poor naming strategy using numbers, which I don't like, and maybe people in the development house, they will also not like. So I was talking about policy, like requirements management policy, And we should have a requirements management policy, because if we don't have a policy, that means we don't know clearly what we should do if there is a new request, or if there is a new change request in the requirements. So policy have many definitions. The Cambridge Dictionary defines policy as a set of ideas or plan that are officially agreed by a group of people based on their organizational needs. So that's the core part of the policy. So it should be a set of ideas or principles or plans that are agreed by the concerned parties, or by the group of people, that will help their long-term goal, or their business objectives or business goals. So these definitions are general definitions, but they are also applicable to requirements management, or also in software engineering in general. So we should have a policy also for our requirements management. And the goal of the requirements management policy is to define some procedures, or uh, some systematic approach to face or accept or reject a change in requirements or change in the system. So there are many benefits. Of course, this works. So these policies for requirements management, they work as a guideline for the people. And if there is a guideline, we know that people will be less dependent on each other, and they can work more independently. And also, if you have a well-defined requirements management policy, this will also help you to identify problem areas, uh, because your requirements might change. Not only that, your process might also change. So if you are following a policy over, let's say, a long over a year or over 2 years, and you see that there are something that is not working in the process or in the policy, you might change your policy also. And then policy versus standards. We also discussed, uh, uh, let's say, requirements document standards, but now we are also talking about policies. So what are those? What are the differences between policies and standards? So policies usually tell you what you should do, not, let's say, in which order, but what you should do. But standards say how you should do, or how you should implement those policies. So that's the uh, core difference between policies and standards. Policies might change depending on your needs, but standards rarely change or never change in general. Uh, and what are those things that should be in a standard or good requirements management policies? So a good requirements management policy, of course, first should describe a set of objectives that it want to achieve through this management policy, and then it should produce some outcomes, or let's say some reports uh, as part of your requirements management policy. So if you are, let's say, changing to a number of requirements, you should have a report at the end, which requirements got changed, why they got changed, what was impacted by those change, and so on. Uh, it should also define the standards as part of the policy. So which standards it will follow, for example, for defining the requirements document, or to express the requirements itself. And also One of the key part is change management. So how changes in the system or in the requirements should be handled. This should be also part of the policy, requirements management policy, and how the requirements will be reviewed or validated. So requirements validation should also have a policy. In other words, requirements validation is also part of the requirements management, which should be defined or well defined as part of the requirements management policy. And also what types of traceability information we want to store or preserve, and how those information will be used or managed. This is also part of the requirements management policy, or we should define as part of those policies how we want to maintain traceability information. Then we are talking about traceability information, and when we talk about traceability information, we mostly think about requirements traceability. So in the policy or as part of the policy, we should mention specifically what traceability information we need to maintain or specify for each requirement, and how it should be stored or represented. So there could be multiple or different types of traceability information. For example, traceability between requirements. So basically the dependency between requirements, the dependency between the requirements and the system design. So this is also another types of traceability. So which part of the system design is linked to which requirement, and then the traceability between requirements and components, and at the same time traceability between requirements and documentation. So which part of the documentation is documenting which requirement. So these are different types of traceability information, and if you maintain them properly, that means your requirements are traceable. And not only that, it will be very easy to reflect changes because you are storing this information systematically. So traceability policies are most often written policies, and again, similar to the previous slide where we mentioned that what are those different items that should be defined as part of the requirements management policy, we have a similar list that should be defined as part of our traceability policy, or the information that we want to store if we want our requirements traceable, to be traceable. And in that policy, we want to, first of all, need to define what information we want to maintain, and then what techniques we want to use uh, to maintain that traceability, because there are many different techniques. I think I will introduce two of them in the next slides. And then the stakeholders or the people and their various role uh, as part of the traceability policy. So which people is responsible for maintaining this traceability database or data set, which people will be responsible for, let's say, handling the change request, uh, which people will be responsible to convey the change to the developers, and so on. So there are many roles. And also how to handle the exceptions, because not all uh, traceability information might not be available. Not all requirements might not have all the traceability information. So there could be some exceptions, some failures, some constraints. So how those will be handled if there is some missing traceability information. So this should be part of your traceability policies. And usually we should try to follow a very simple policy or lightweight policy, because if it's a heavy policy that takes a lot of your time, or it's hard to follow, then people mostly ignore them. So try to have a simple policy when you or about how you want to keep or store or manage your traceability information for the requirements. So what type of traceability information that we want to maintain, or there are possibilities? That one traceability information is requirements to source. So who proposed this requirement? Then traceability between requirements and rationale. So why these requirements was proposed by that source. Then requirements versus requirements. So if there is any other dependency between or among requirements, then requirements with the architecture and design. So which part of the architecture or which part of the design implement which architecture, and also the requirements versus interface. So some requirements might require some external interface or third-party system. So which interface we need from that system for this requirement, and this kind of traceability information. So I was mentioning that there are several techniques to store traceability information or maintain traceability information. One of them is the traceability table. It's basically a cross-reference matrix uh, where you keep your requirements both in the row and in the column, and you simply mark certain requirements that are dependent on that requirements. For example, requirement one depends on requirement 4, requirement 2 depends on requirement 3, requirement 3 depends on requirement 1 and 4, and so on. So this is known as traceability table, but it does not give you much information about what kinds of dependency it is. So then another way, or to improve this traceability table, there can be another way to represent this traceability information, that is by different relationships, specifies, requires, and constraints. So we can see that, or we can read in this way, that requirements R1 requires R4, requirements R2 constraints R3. That means you have to implement R3 first in order to implement R2, or vice versa. And then requirement 3 specifies R1, but it constrains R4. So if there can be many other different types of dependencies or traceability information type for the requirements. But one of the problems for this kind of traceability information is that you can easily say that R1, so R1 is specified by R3, or R3 is constrained by R2, but then you can find information this from left to right, but when you want to get the picture of from the other side, it's not very easy. And to overcome this problem, basically there is another technique that is, I think, in the next slide. But this technique of traceability table, it's good for small number of requirements, not for large. Because if you have, let's say, 100 requirements, you will have 100 by 100 metrics or table. That is not very feasible to manage. So to manage large requirements, or to trace the requirements more efficiently, there is another way, that is a list or traceability list that basically keeps a list of the requirements and only store the information that has some dependencies. In that way, you not only save memory, but also you save lookup time for this traceability information. Mm, and also, this list is less prone to error than traceability tables, because in the traceability tables you have to work a matrix, you have to uh, identify uh, correctly which cell you are referring to find some certain dependencies. But in this list, you can find the dependency or the relationship for R3 only by looking at it, and you can get all the requirements that are dependent on it. Uh, okay, I think I provided a wrong information here. So this traceability list is basically more problematic to go or to find the inverse relationship. But this table, traceability table, is easier to find, because if you find from R1 to R3, it should not be a problem also to find the reverse uh, relationship from R3 to R1. But this traceability list has the problem to find inverse relationship. Sorry. And this kind of traceability list can also be used to prioritize your requirements. For example, if we are saying that R1 is dependent on R4, R2 is dependent on R3, that means we must implement R4 first before R1. So we can build a graph like this where R4 will come before R1. And since R2 is dependent on R3, that means R3 must be implemented before R4, R2. So R3 will come before R2, and so on. So in this way, if we can build a graph, we can see from the graph that R4 should be implemented first, and then R1, then R3, and then R2. So in this way, we can also prioritize requirements or order the requirements. Then we should also have a database for requirements. Since we are talking about requirements management, basically it's good to maintain a database for the requirements to manage them easily or to manage them well. There are many benefits, including search functionalities, including uh, automatically process the requirements and so on. And not only that, you can link easily those requirements by to your system uh, by extending your database, like by adding more columns, and in this way you have basically more traceability information. So that this is a good thing to use database for managing the requirements. But the question is, do you need the database? And you can find based on these questions if you need a database or not. For example, you might not need a database if you have few requirements and they are very well described using clear language and in very short sentences that are easy to understand, and you do not need to correlate or uh, concern about long list of requirements. But if you need to trace, or if you need to handle hundreds of requirements that has many dependencies, uh, that's a part of the large system. And since you have large sets of requirements, they will be changing in the near future. So you should have a proper policy for change management also, and all this. So handling all these things. Then also, if you do you have any database skills, or if you have database skills, what type of skills you have? Do you have skills for relational database? Do you have skills for NoSQL database, and so on? So depending on many criteria, you pick whether you need a database to store your requirements. Because at the end of the day, if you have a database uh, that is useful for managing the requirements. Uh, in the early stages, there were relational database that was mostly used, but these days there are also NoSQL databases. So you do not need to worry about only storing text, the requirements descriptions. You also can store designs and various other artifacts as part of the NoSQL database. We should also identify global requirements or global system requirements, uh, and identifying them as early as possible is also good for your system requirements, because if you miss any of the global requirements at the later stage, or if you don't find or fail to find certain global system requirements, they will be super expensive to re-implement, or they will be super expensive to change your system. So try to know your global requirements as much as early as possible to minimize future change cost. And to identify global requirements, again, you can come up with some uh, sets of questions. I think there is 6 questions, and some of the questions could be yes, or some of the questions can have no answers. But for example, if is the first question says, is the requirement expressed in a very general way? If this is yes, of course, this is a general system requirement. And in this way, you ask yourself each of these 6 questions. And if your first 3 questions answer yes, and your last 3 questions answer no, that means that is a global system requirements. So in your requirements elicitation phase, or during your requirements analysis phase, or even during your requirements validation phase, if you ask these 6 questions as early as possible, you can identify your global requirements. And most of the time, those global requirements are non-functional requirements that are applicable to the whole system rather than to a single component. It's also an iterative process, so you might not come up all with your global requirements and in the first place, correct? But you should do it several times. Also, I try to identify volatile requirements, because there could be some requirements that are highly change prone, and if they are changing often, uh, that is also a problem for the developers and the testers, because they need to change their implementation, or they need to change their test and so on. So it's always good practice to identify your volatile requirements in as early as possible. And benefits include, for example, you can plan your change efficiently, or you can define your change um, change request policy or requirements management policy accordingly. What you will do with those highly changing requirements. And one good design decisions, for example, if you know that this requirement might change a lot, you you implement it independently in a loosely coupled fashion, so that if it's changed a lot, it does not affect significantly other components. So it only changes itself, and you can replace it only that component. And then you can, of course, identify volatile requirements and tag those requirements using some like Richter scale points. So one for fairly stable, 2 for subject to medium term change, or 3 for likely to change in the short term. So basically, uh, requirements with 3 points or requirements that are likely to change in short term should be implemented as a loosely coupled fashion. Uh, so there was a question: is let me show the question on YouTube. So is a login to an user account a possible global system requirement? Yes, it can be a. So if it's about authentication, it can be a global system requirement. But I'm just telling you based on my understanding. Probably for this requirement, you should ask those 6 questions against this one. And if it's yes to the first 3 questions and no to the last 3 questions, then it's a global system requirement. That I can say. Sorry. But in general, yes, authentication is a global system requirement, because you do not want an authenticated user to go through your every part of the system or access all your information. So that's about identifying volatile requirements. And then there basically are 4 types of volatile requirements. One is the mutable requirements that might change due to the environment or the operating environment. There can be emergent requirements, because we might not uh, define the requirements well enough in the beginning, but as the system evolves or as the time goes, we might have better picture of those requirements. So those are emergent requirements. Then there is also consequential requirements. If you sometimes make some assumptions about the system, and if your assumption changes over time, or if you later found out that, okay, the assumption that I made was not correct, in that case, those requirements are consequential requirements. And then also compatibility requirements. So if you define or elicit a requirements that is compatible with your process at this point, but if your process change, your requirements might not be compatible anymore with the process. So it depends on other processes or other third-party equipments, and those are compatibility requirements. You should also record rejected requirements, because not only those are rejected and you should forget them, rather, even if you sorry, even if you rejected them, they might be useful, or they might be again needed for your system. So what you should do, the database you are maintaining for your systems, for your requirements, you should have another column or status in that document, in the database, that's called status field, let's say. And you should have a value for the requirements, so either accepted or rejected or under consideration. So these rejected requirements in the future might be accepted, who knows. So it's better to keep the rejected requirements rather than forgetting them. Okay, so that was about the requirements management part. So as you can see, for requirements management, there are many aspects of the management side, including how you handle the changes, how you record that, keep the record for the rejected requirements, how you keep the record for volatile requirements, what information you store for traceability and so on. So how you maintain traceability and so on. So, and the lectures that we had yesterday, the other day, and today was more theoretical aspect of this part of the course. So we are done with the theory. But for the next lecture, that is on Tuesday, probably I will be doing it live from campus. Hopefully, if I am feeling well. For the next lecture, basically, I want you to be prepared with your laptop, and you need to install some tools. So one of them is this OCL. So based on this slide, or what I will do, I will also publish a tutorial for which you can follow and do some installation or do some tutorials, like hands-on tutorials based on that PDF. So I will publish a PDF. So you will install first of all this tool, OCL plugin, on your Eclipse, and then you should download another cool tool called STS. So it's a modeling tool where you can model your requirements, in particular the security aspect of the requirements. So although you model the functionalities of the functional aspect of your requirements, but what you do is basically you integrate security aspects of those functionalities. So you need to download this tool, and I think you need to open up an account, or in order to get the download link, you need to provide your email address and so on. So make your computer prepared by installing this tool, and also the OCL for your for the next lecture. And also these two tools will be used for your assignment. So there is no easy way out. Basically, you must install these two tools anyways. Someone was asking, will next lecture, that is hands-on, also be streamed? Yeah, that one will be also streamed. I hope. For sure that will be streamed, but I'm not yet sure if I will do it from campus or from home. Hopefully I will be feeling well, and I will do it from campus. But let's see, fingers crossed. And another question I found on YouTube is that, is this tool available for IntelliJ too? I have never used it with IntelliJ, but it should be there. But yeah, try to see if there is no plugin for IntelliJ. You should install the proper version of Eclipse and then this OCL plugin. Okay, so I think we are end of the lecture. If you have any questions, feel free to ask. Else, we will be having one lecture next Tuesday and one tutoring session on Thursday. Don't forget to book your tutoring session if you need only for the assignment, or if you need any help for some kind of installations and so on. So see you next Tuesday. So next Thursday will be no lecture. It's a tutoring day. As I mentioned several times, I published tutoring slots on my Moodle. So for this part of RE, you have 3 lectures. Two were already done this week, and one next Tuesday, and then the Thursday will be tutoring. Eclipse 2019 should be okay. I think it should be okay, because my Eclipse version is also not the latest one. But go to that OCL website and look for which Eclipse it is recommended. Yeah. So have a nice afternoon, everyone, and see you on Tuesday. And another question, we got the assignment next Tuesday, right? Yes. I will briefly go through the assignment next Tuesday, and the deadline, I guess, it's on February 11th or the Friday. I don't remember the date, but yes, it's next Friday. So bye bye.